Hello everyone. Today we are going to be talking about electrostatics, which is the motion of an electric charge at rest, that is when velocity equals zero. Now we have two major charges, which are the positive charge and the negative charge. And when we have two equal charges placed beside each other, the force between them is known as the force of repulsion. And that's why in the law of electrostatics, when two like charges are together, they repel one another. However, when we have two different charges, positive and negative, the force between them is going to be the force of attraction, because unlike poles attract each other. Unlike poles attract each other. Now then, moving away from this, Coulomb's law states that force equals Q1 Q2 over R squared. So then what does this expression mean? Coulomb is trying to say that the force of attraction or repulsion between the positive charges here or the positive negative charges here is directly proportional to the product of the charge 1 and charge 2. That is, to the product of positive charge 1 here and positive charge 2 here, or positive charge 1 here and negative charge 2 here. And it's also at the same time trying to tell us that this same force of attraction or repulsion is inversely proportional to the radius, that is the distance between them. And let's assume we have our charge 1 here and we have our charge 2 here, and the distance between them is this. This distance is known as the radius, and this charge most times is measured in micro coulombs and micro coulombs here. So I think this explains Coulomb's law. Now, combining these two formula, our final formula is going to be F equals KQ1 Q2 over R squared, where our K is the constant of proportionality. Our K is the constant of proportionality. So the question here says find the magnitude and nature of electrostatic force between two charges Q1 and Q2 separated by a distance of 0.4 meter. First, let's draw out our expression. That's our Q1 here and our Q2 here, separated by a distance of 0.4 meter. Our Q1 was given to be 5 times 10 raised to the power minus 6 coulombs, and our Q2 was given to be minus 3 times 10 raised to the power minus 6 coulombs. Now then, notice the convention given here, negative. This shows that the two charges we were given, Q1 and Q2, are opposite to each other. So what are we going to use? What are we going to be using? We are going to be using the formula given to us initially, which is F equals K Q1 Q2 over R squared. F equals K1 Q2 over R squared. Okay, so F equals K1 Q2 over R squared. Our Km is the constant of proportionality, and its value is 9 times 10 raised to the power 9 times the value of our Q1, the value of our Q2 as given, and our R is 0.4 meters squared. So using my calculator here says F equals 0.844 Newton. Now that is the magnitude. That's the magnitude of the electrostatic force. But what about the nature? As you can see, I told you initially that the two charges are opposite to each other. And according to the law of electrostatics, when two charges of when two different charges are brought together, negative and positive, the force between them is going to be the force of attraction. So the nature of the electrostatic force is the force of attraction. Let's move on to the next question. Okay, this is the next question. Using the same method we've used before, as you can see, the question here says 2-point charges Q1 and Q2 are at 0.2 meters apart. Find the resultant force exerted on Q2. Drawing our diagram again, let's say this is our Q1 and it exerts a force on charge Q2. Our charge Q1 is positive, our charge Q2 is negative, and the kind of force it can exert on charge Q2 is the force of attraction because of the negativity. So therefore, they have the distance of 0.2 meter between them. Using our Coulomb's law formula, which is F equals KQ1 Q2 over R squared, our 9 times 10 raised to power 9 for the constant of proportionality, value of Q1 times value of Q2 over our distance squared. Now, our final answer using our calculator, the final answer is going to be 2.25 Newton. Alright, the last question here says 3-point charges Q1, Q2, and Q3 are at a point x equals 0.2 meter and 0.4 respectively. Find the resultant force exerted on Q2. First, let's draw our diagrams. Our Q1 is said to be at the origin of 0. Our Q2 is said to be at 0.2, Q2 here, and our Q3 is said to be at 0.4. That's our Q3. This one is our Q1, origin of 0, 0.2, and 0.4. Now the question is to find the resultant force exerted on our Q2. Now our charge Q1 is positive, charge Q2 is negative, charge Q3 is also positive. That implies that the force that will be exerted on Q2 by Q1 alone is the force of attraction going towards the left. That is, Q1 is going to attract Q2 towards itself. Likewise for our charge Q3, Q3 is going to attract Q2 towards itself as well, because Q2 is the only one that is negative there, whereas Q1 and Q3 are both positive. So that means that our charge Q2 here is going to be drawn in two different directions. Now, to first calculate for our Q1, the force exerted, or the force of attraction or repulsion between our charge Q1 and charge Q2, that is F12, equals KQ1 Q2 over R squared, and that is our 9 times 10 raised to power 9 times our Q1 value, Q2 value, all over R squared. I think our R squared there is 0.2, the distance between Q1 and Q2. So using our calculator, our F12 equals, so our answer from the calculator is F1,2 equals 2.25 Newton. Now the next thing we have to solve for is our F2, F3, that is the force of attraction between Q2 and Q3. So our F2,3 equals KQ2 Q3 over R squared, and that is our 9 times 10 raised to power 9 times our value of Q1, Q2, our Q2 and Q3 instead, all over R squared. So our sorry for that, R was given to be, now as you can see here, the distance between Q2 and Q3 is 0.2 to 0.4. That means that our R equals 0.4 minus 0.2. So our R also equals 0.2 meters. So the R here is going to be our into bracket 0.2 meters squared. So using our calculator, our F23 is going to be, so our answer here is 1.35 Newton. Answer is 1.35 Newton. However, that doesn't end there. Using our components to resolve F12 and F23 into a single force acting on Q2, our F net is going to be F1,2 plus F2,3. But recall I told you before we started solving that Q1 is pulling Q2 towards itself to the left, and our Q3 is also pulling Q2 towards itself to the right. That means that Q2 is going in two different opposite directions, and eventually our F12 will be 2.25 minus, because of the opposite direction, minus 1.35. So our final answer for F net is going to be 0.9 Newton. So that concludes our question here. Thanks for watching.